So guys, today I am going to talk to you about an important data structure called hash tables. So leave this part for now. So I hope everyone is familiar with the concept of arrays. So as we all know, an array is a collection of items stored at contiguous memory locations. So let us assume that we have an array of how much 12 elements, the index starting at 0, and let us say if we have to check if an element 5 exists in that array. So taking the naive approach, how will we find if an element 5 exists in that array? So we will iterate over the array and find out if the array at the ith element is equal to 5. So as we go on increasing the index of array, we will find eventually that the array element 7th is 5, and yes, it exists. So what is the complexity of this operation? So in big O notation, it is O of n, that is a linear time. So if we have to check whether an element is present in the array, we have to use linear time. So the question arises, can we do it better in any way? So this is why hash tables are there. So what is a hash table? Hash tables are a type of data structure in which the address or the index value of the data element is generated from a hash function. So many new words are here. So index value is basically, as this is an index value for an array, in the same way, since array consists of contiguous memory locations, this index is gradually increasing from 0 to the size of an array minus 1. But in case of hash tables, this index value is determined from an hash function. So what is a hash function? So a hash function is basically something which outputs an index on the basis of given inputs. So let us say the following are the keys. Basically these are the inputs to the hash function. Suppose John Smith. The hash function outputs a single index, in this case 02. Similarly for the second element, it outputs an index 01. If we keep on doing this, we'll find various indexes for various inputs. Please note here that two elements can have the same index value, and this is called collision. This will be addressed in the further slides. So how does a hash function works? Let us say, so first of all, hash function converts an object into an integer. So let us say there are 4 objects, object 1, object 2, object 3, object 4. They can be anything, either a string or a number or anything. So this hash function generates hash codes. This can be any operation. Let us say if the object 1 is a string, then we can say, suppose, sum all the ASCII values of its characters and we'll get some hash code. To generate indices, what we do is we take the modulo of these hash codes with the size of array, so that all the table indices are in the range from 0 to the size of an array. So let us say for object 1, the index obtained is 4. So that is why, so object 1 will be placed at the 4th index. Similarly, for all other items, we will see for object 2 it is 1, object 2, this is 1, object 3 it is 3, object 3 is at position 3, object 4 is at position 0. So in the previous slides, we saw that 2 of the elements were having a collision. So this is very frequent, especially when the size of the array in the output of a hash function is very small as compared to the number of objects. So how do we address these collisions? One way to address these collisions is using chaining. So what is chaining? So let us say, suppose John Smith and Sandra Dee are having the same index. So what we do is basically create linked list. This is a linked list with a key and a value pair. So whenever a collision occurs, what happens is the next element is just linked to the previous element. Like first we saw that the index for John Smith is 152. So we created a pointer and created an element of a linked list, John Smith, with the key and the value as this one, 521 1234. Now what happens is we carry on our regular operation. See, Lisa Smith, it is 001, no collision. Okay, we created a linked list and we just created the value. Now as we go on to Sandra D, we find out the index is colliding with the original one. So what we do is, now we create a pointer from the existing element and create a new element called Sandra D, with the key Sandra D and a value 5219655, whatever, it can be anything. So this is one of the way to address collisions. But what happens in this case is, let us say we have to find Sandra D. So, what is the value for Sandra D? So what happens is, we find using the hash function, we find out that it is indexed at 152. But at 152, we'll have to traverse through all these elements of the linked list to reach up to Sandra D. So let us now, in this example, since the input is very small, size is very small, so we can the complexity doesn't matter. But if the input is very large, then the worst case complexity could be O of n, like a linear chain of linked list will be created, and the worst case might be the element you're trying to find is at the end of the linked list, so it may take up to O of n. Another way to address these collisions is using open addressing. So what open addressing does is, let us say John Smith arrives first, so we assign it 150. Let us say 152 it is to be assigned at 152th index. So we assign John Smith at 152nd index. We carry on with Lisa Smith, Sam Doe, no problems at all. They are very different indices. But again, Sandra D, it has to be assigned at 152 index. But we see that 152 is already occupied. So what we do is, we go to the next address, and that is 153, and insert Sandra D there. Now on further adding further elements, let us say Ted Baker. Now if the hash function outputs 153 as the index for Ted Baker, we see that 153 is again occupied, so the next address is assigned to Ted Baker. This is another way of using reducing collisions by using open addressing. Now the main question is, how do we implement hash tables? So hash tables are also known as dictionaries in Python, or it is known by other names like or unordered set or unordered map in C++, and hash set and hash map in Java, etc. So how do we actually implement this in Python? So let us take an example. So let us say the problem says that you have to find the first recurring element in an array. You are given an array of elements, let us say for now they are integers, and you have to find the first recurring element, that is, in this case, suppose 1, 2, 3, 4, 8, 6, 9, 4. You can see the 4 is appearing the second time. So this is the first recurring element. All the elements before 4 have a count of 1. So you can pause the video and try to solve it using your own approach. So one of the approach to solve these problems is using dictionary. What we can do is, for every element that we see in an array, we'll check if the element is already present in the dictionary. That is, see, the dictionary in Python an empty dictionary in Python can be created using this syntax. Dict1 is curly brace, just curly braces. This says that we are creating a dictionary object which is empty. So the solution for this problem can be said in the following form. Let us say for every element in an array, we'll check if the element is already present in the dictionary. If it is present, then it is the element which is recurring, so we'll print the element and break the loop. Or else what will we do is, if the element is not already present in the dictionary, we will add that element to the dictionary and set its value to true. So let us iterate over the array. So in first case, let us say when the element is 1, we will check if it is in a dictionary. We say that the dictionary is empty, so this is false, so this won't be evaluated. Hence it will go and put on the value for C. What it will do is it will add the element 1 into the dictionary with a value of true. Okay, for every element it will keep on doing this. Second time, when the element is 2, it will see if 2 is present in the dictionary. It's not present. It will add element 2 to the dictionary and set its value to true. If we keep on doing this, by the time we reach the first recurring element, suppose we go on adding up to 1 2 3 4 8 6 9, we reach 4. Now it will see if 4 is in dictionary 1. Yes, it is in dictionary 1, so it will print I, that is the element, that is 4, and break the loop. So this is what we had expected. We will try to run. I had already run this. Let us change the code. Let us say it is 10. So now the first recurring element is 2. The code should output 2. See, so this is how we can use the dictionaries or hash tables to solve problems.